Hi everyone. So today we are going to understand the chapter on metals and non-metals. The notes have been prepared comprehensively only from NCERT, and the whole motive of the notes is that we only cover up efficient topics. We don't we cover the topics that are NCERT covered and that are efficient from the exam point of view. And you don't have to consider various sources to study. NCERT, science NCERT is the best way to prepare for science exam. Once you complete the notes from your science NCERT, then you should refer to some you like or like previous year sample papers. So that would be enough for both the exams. So today our topic is metals and non-metals. This is a chapter that you also have studied in chemistry, and the chapter is very interesting. And I'll try to cover up each and every point that I really find important. And this video is going to be prepared in two versions. So this is part one, and part two will be uploaded soon. So let's start it off. First, you know that elements they can be classified into metals and non-metals. There are metals like copper, iron, aluminium, magnesium, sodium, and lead. And there are non-metals like carbon, sulfur, iodine, oxygen, hydrogen, etc. Metals are generally solid in nature, except mercury, which is liquid in nature. The non-metals are either solid or gases, except bromine, which is a liquid. So metals are generally lustrous, they are ductile, they are malleable, and they are very good conductors of heat and electricity. But non-metals are quite the opposite of metals. They are not lustrous, they are not ductile, they are not malleable, and they are poor conductors of heat and electricity. But there will be few exceptions that we will be covering up in the later part of this stage. So before that, we would like to understand some properties of metal first. These are the properties that you have been familiar with if you have studied the chapter metals and non-metals in class 8, which focuses on the physical properties of metals and non-metals. So we already had studied in class 8. The properties are like malleability, ductility, and sonorous in nature. The first one is malleability. Malleability is a property of the metals by which they can be beaten into thin sheets. Then we have ductility. Ductility is something, let me change it to pen. Ductility is when metal can be converted into thin sheets, thin wires. That is called ductility. So the question here is that which is the most ductile metal, and that is gold, and you should remember that. It can be asked in erosion and region question. Now, we have already studied that metals are lustrous, that are malleable, and they are good conductors of heat and electricity. And they're solid at room temperature, except mercury. Mercury is liquid at room temperature. And metals, generally in their pure state, they have a very shining surface. And due to the shining surface, they carry a property called metallic luster. They are very shiny in nature naturally. That is why they are called lustrous. Okay. And what property is of metals that by which they can be converted into thin sheets, and that property is called malleability. Metals are generally very hard, and but the hardness can vary from metal to metal. For example, there are alkali metals like sodium, lithium, and potassium. They are very soft and they can be cut with a knife very easily. Okay. Metals are generally good conductors of electricity. That is why the wires are covered with PVC. Okay. And non-metals are generally soft, but there is an exception where diamond, which is the hardest non-metal known, it is an allotrope of carbon. Diamond is an exception where we can say that non-metal is quite strong. Okay. But non-metals are generally hard, but diamond is an exception. Again, graphite is an exception, like it is a good conductor of electricity. Okay? And iodine is another exception of non-metal, which is lustrous in nature because we studied that metals non-metals are generally non-precious. Again, we have exceptions like gallium and cesium, which are metals and they have very low melting and boiling point. They have very low melting points. Generally, we study that metals have high melting points, but gallium and cesium are the exceptions. Okay. Now comes the second page where we are going to study if metals. Now we are going to cover up about the chemical properties of metals. Okay. So what happens is when metals combine with oxygen, they form metal oxides. Okay. So this is one question that can be framed. The metal oxide uh, are the consequences of when metals react with oxygen. Okay. For example, like we have studied in the first chapter chemical equation class 10 that magnesium when burned is in air or oxygen, it forms NGO. Okay, that is magnesium oxide and it is a white ash. Similarly, when copper is heated in air, it combines with oxygen to form copper oxide, which is a black oxide. So it is black in nature. So Cu plus O2 forms 2CuO. Let me just remove it, or I can remove it. So it forms CuO, okay? Copper oxide. Similarly, aluminium forms aluminium oxide. All metal oxides are basic in nature, okay? But we have some exception like aluminium oxide and zinc oxide. They are amphoteric oxides, okay? They show both acidic and basic behavior, ठीक है तो यहाँ पर क्वेश्चन कैन बी फ्रेम what are amphoteric oxides so amphoteric oxides are such metal oxides which react with both acid and bases to produce salt and water because they act as both acid and base ठीक है let's see for example Al2O3 when reacted with an acid it is forming aluminium chloride which is a salt and H2O which is water. Again, when I am reacting aluminum oxide with sodium hydroxide, it forms sodium aluminate, which is a salt again, plus water. So in both the cases, the salts are formed. Even the aluminum oxide is reacting either with HCl, it is forming a salt. And when aluminum oxide is reacting with NaOH, which is a base, it is also forming a salt. The salt formed is however different. Okay? Now we are going to study about metal oxides, the nature of metal oxides. More. Like metal oxides are insoluble in water, but there are some other metal oxides which form alkali in water. Alkalis are nothing but the bases when they are reacted, when they are dissolved in water, they form alkali. Okay, so not every metal oxide is dissolved in water. Some are not, whereas some are. So the metal oxides which are soluble in water form alkali, like potassium hydroxide or sodium hydroxide. Okay, sodium oxide and potassium oxide dissolve in water to produce alkali. The question can be framed which two metals form alkalis when they are dissolved in oxygen or water. So it would be sodium and potassium. So this is the reaction where Na2O plus H2O gives NaOH and K2O, which is potassium oxide plus H2O gives potassium hydroxide, which is again an alkali. Sodium is the most reactive metal. The reaction of magnesium is less vigorous, implying that it is not reactive as sodium. But burning in oxygen does not help us to decide about the reactivity of zinc, iron, copper, or lead. So now we are going to study about more. All metals do not react with oxygen at the same rate. Different metals show different reactivity towards oxygen. For example, potassium and sodium, they react very vigorously and they catch fire if they are kept in open. So they are kept in kerosene oil to prevent their contact with oxygen and water. And there are metals which react with oxygen at very ordinary temperature like zinc and magnesium and aluminum and they develop a thin layer of oxide on them naturally. हमने first class में we have studied one case where we were told that before we are going to burn magnesium level in oxygen, we are supposed to rub it with sandpaper. Why we were supposed to rub it with the sandpaper so that we can remove the layer of magnesium oxide which is naturally formed as the result of oxidation of magnesium with oxygen. Okay? So magnesium forms magnesium oxide naturally. Now, why this protective oxide layer is formed? It is formed to prevent the metal from further oxidation. Okay. Now, there is another point which is studied that all metals do not react with oxygen at the same rate. Some react very faster, like sodium and potassium. Some react at a very normal rate, like magnesium, aluminum, zinc, and lead. But there are other metals like iron which do not even react on heating. Okay, so iron does not burn on heating, but there are iron filings that burn vigorously when they are sprinkled in the flame of the burner. Now, another thing is copper. Copper does not burn. That is why they are used in utensils. Okay, but the earth metal is coated with black colored layer of copper. So, copper generally doesn't get burned, and due to which most of our utensils are made up of copper and aluminum, and they form a black layer of copper, which is copper oxide. Okay. Silver and gold do not react with oxygen even at high temperature. So this is one question. Which are the two metals that do not react with oxygen even at high temperatures? And that would be silver and gold. Now one more topic is anodizing. So anodizing is what? Anodizing is a process of forming a thick layer of aluminum. What happens is aluminum develops a thin oxide layer when it is exposed to air. This oxide coat makes it resistant to further corrosion. The resistance can be improved further by making the thicker lower layer thicker. During anodizing, a clean aluminum particle is made the anode and is electrolyzed with dilute sulfur gas. The oxygen gas evolved at the anode reacts with aluminum to make a thicker protective oxide layer. This oxide layer can be dyed easily to give aluminum particles an attractive finish. So what happens is, so aluminum is not, we studied that aluminum naturally forms an oxide layer Al2O3 naturally. So in order to, and this protective layer protects the aluminum from further corrosion. So in order to strengthen that layer, what we do is we do the electrolysis. Okay. What we do is there is an anode and there is cathode. The anode is usually positive in nature and cathode is usually negative. It cannot usually it is negative. And in the liquid we kept dilute sulfuric acid. What we do is we take a clean aluminum and we make it node. We make it as node. Okay. So when we run the electricity through hydrochloric acid, the oxygen, due to its negative nature, it will go to the anode, which is positive in nature, and it will react with aluminum because we made aluminum the anode. So it will form further aluminum oxide, and that would thicken the layer of aluminum oxide, and it will also give the shiny surface, and hydrogen will go to cathode. So, okay, next we are going to cover it in the next session. So in this, we are going to study how metals react with water, and then how metals react with dilute acid because they form basic uh, oxides, okay? And then we are going to study what is aquaresia and how metals react with the salts of other metals. And then we are going to cover up about the ionic compounds, okay? So please be tuned for the next few more videos. I was thinking that I will be able to cover up in two parts, but the chapter is uh, really vast and it takes time. So I hope I will be covering this chapter in almost 5 videos. So stay tuned for more videos. And if you want this PDF for your studying, then you can comment. And the PDF price is very nominal. This particular is of 15 rupees, and you can get it on WhatsApp most probably or email, and you just need to pay the nominal price of rupees 15, like 15 for one PDF. So if there are two PDFs of one chapter, if you want to buy two PDFs, then it would make rupees 30. So let me know if you need periods, and these notes are really very efficient for your uh, like studying. Like from the exam point of view, they're very important. Like once you are done studying NCERT and now you only want to revise important topics. So these videos are really examination and they would really help you a lot at the last moment. So thank you so much for watching this video. Please make sure to like, subscribe, and share. And if you have any suggestions, please let me know in the comment section. Thank you.